The CRT, short for cathode ray tube, produces the image that we see on our TVs and computer monitors. The ones that aren't LCD or plasma, that is. Believe it or not, the cathode ray tube was invented back in 1879. A CRT is made up of two main components, a large glass bulb and an electric gun. CRTs start with a molded glass bulb. Workers remove microscopic debris with a high-pressure water rinse. Then they spray hydrofluoric acid to clean the glass at an atomic level. Phosphor solution is poured into the bulb. Phosphor is an organic compound that emits light when struck by electrons. The phosphor particles settle and form a chemical bond with the bulb face. Workers pour off the excess solution and clamp the bulb over a nozzle that sprays clear lacquer over the phosphor. The centrifugal force guarantees an even coat. This worker paints a conductive coating over the anode button, which will provide a flow path for the electrons that'll light up the phosphor particles. Meanwhile, another worker drops an aluminum pellet into a tungsten coil. He places the bulb over a vacuum device and draws out the air. Then, he applies an electrical current to the coil. It evaporates the aluminum pellet, which spreads a mirror-like coating on the inside of the bulb. Now, they heat the bulb to 425 degrees Fahrenheit for 1 hour. This bakes out the lacquer and any trace of moisture. Using a high-temperature flame, a worker aligns and fuses a glass neck to the bulb. Then he paints it with the same conductive coating. This assembly is part of the electron gun that goes inside the bulb. It shoots electrons at the bulb's phosphor particles that lights them up, creating the image we see on screen. Workers stack the grip cups that focus the electrons on the screen. Then, using beading glass, they align and fuse them into position. Robots heat and affix the beading glass to assemble the electron gun components. Then, the gun is cooled with pressurized air. Once cooled, a worker builds up the gun and inserts the completed gun assembly into the bulb. Next, he positions the bulb on a glass-blowing lathe and cuts excess glass from the neck. Using a graphite paddle and a high-temperature torch, he mates the glass neck to the electron gun stem. This ceramic heating coil melts that green glass pellet to keep the bulb under vacuum. The tube is heated to 750 degrees Fahrenheit for 2 hours, and once again, a vacuum is drawn. To minimize image flicker over the tube's lifespan, workers condition the bulb using a high-voltage coil. It smooths any rough surfaces that might remain on the electron gun. Finally, workers apply electrical connections to the electron gun to bring the cathode ray tube to life. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.